Hello, algebra students. Mr. Lawrence here, and this is cluster number 3. It's going to deal with variables on both sides, and I know I've talked about these before, and some of you really get freaked out over them. It's really no big deal. The real reason you don't like these equations is because there's an x term on both sides of the equation. All right, let's just take one away. I didn't say throw one away. I said take one away. Remember back to first grade, take away means subtract. So you see, I've got a 7x, a -3, a 5x, and a 12. I'm going to take one of these x terms away. I recommend taking away the x term with the smallest coefficient, okay? But you don't have to. That's just a good way to do it. It'll keep your coefficient positive in many cases and help keep you from making some silly mistakes. So I'm going to take away 5x from the right-hand side. But since it's an equation, I'm going to take away 5x from the other side. All right, when I do that, I'm going to end up with a 2x minus 3. These 5x's will have canceled, and I'll have 12 left. All right, good morning, Nicole. So now I've got a standard two-step equation. So I'm just going to add 3 to both sides. And then I'll get 2x, and that'll equal 15. Dividing by 2, I need half of 15, and I know some of you really freak out over that. Look, half of 14 is 7, right? Half of 16 is 8. Half of 15 must be 7.5. Must be. All right, so my answer is x equals 7.5. Okay, the solution set, which you'll hear more of soon, would be 7.5. It's the only value of x that makes this equation true. Of course, you can go back and you can plug it in, 7.5, into the x terms, simplify both sides, and you should get a true statement. I'll leave that for you to verify. All right, there are 3 more problems there. I would like you to attempt them on your own. Okay, pause the video, attempt problem number 2, and then see my solution. And then you can attempt problem number 3. All right, go ahead and pause the video. If you're still watching, I'm supposing that you have already attempted problem number 2. Now, you could add 2x to both sides, but remember I recommended getting rid of the x term with the smaller coefficient, and -6 is smaller than -2. So I'm going to add 6x to both sides. Wait a minute, Mr. Lawrence, you said you were going to subtract or take away. Well, I did. I took away a negative, right? Taking away a negative is like adding a positive. So what I had was -6x minus a -6x. And taking away a negative is like adding a positive. So these are going to cancel. Over here on the left-hand side, I'm going to get 6 plus 4x, and that's going to equal 8. And then I'm going to just solve my two-step equation. I'll take 6 away from both sides, yielding 4x equals 2. I'll divide by 4 on both sides. X equals 2/4, but that's not the best answer. I'm going to simplify it down to x equals 1/2. And there we go. And of course we can check it. I'll go 6 minus 2 times 1/2. Following the order of operations, 2 times 1/2 is 1. So this is really 6 minus 1, which is really 5. Okay, the other side, 8 minus 6 times 1/2. Following the order of operations, and I'll get 8 minus 3. Which of course is 5, and so you see it does check. All right, if you haven't tried problem 3 yet, please pause the video. If you're ready, here we go. All right, I'm going to take away the smaller, the x term with the smaller coefficient, so I'm going to subtract 2x from both sides. I'm going to get 8x minus 3 equals 13. Then I'll add 3 to both sides, right? I'll get 8x equals 16, then I'll divide by 2, and so therefore x will equal 8. And there we go. I'm going to leave the check up to you on that one. All right, please pause the video if you haven't done number 4 already. Okay, now here comes problem 4. I have a -7x on the left-hand side. I have a positive 8x on the right-hand side. That means this one is the smaller coefficient, so I'm going to get rid of it. I'm going to take away the negative, which is adding a positive. And when I do that, I'm going to get 5 equals 15x minus 40. Now it's just a two-step equation. By the way, some of you get really bent out of shape with the variable on the right-hand side. Well, you can rewrite it. These two statements are equal to each other, so you could rewrite this as 15x minus 40 equals 5. It doesn't matter as long as you're going to get the right answer. You can write it either way. If they're equal, they can switch places. All right, so let's see here. I'm going to add 40 to both sides. And I'll get 15x equals 45. And then I'll divide by 15. And I'll get x equals 3. Now, one thing that I want to point out that is real subtle, and it gets missed by a lot of students at this age. This equation here, and this equation here, and of course this equation here, and this equation here before I divide it, and this equation here are all the same. Meaning this equation down here at the bottom, this one here says x equals 3, right? All the other equations are equivalent statements. This means x equals 3. This means x equals 3 here, and also x equals 3 there. That's true in the other equations as well. Yeah, check it out. This original equation, and then the 8x minus 3 equals 13, and then the 8x equals 16, and the x equals 8. They all have the same value, okay? They're just different forms of the same equation. I manipulated it down so that the variable was all by itself, but all of these have the same answer. Oh, I have a real silly mistake there I just caught, don't I? Hopefully you caught it. Sorry about that. Glad I kept talking. I shouldn't be dividing by 2. I should be dividing by 8. And then x equals 2. There we go. Silly me. Well, I hope you went and checked it. You would have found that I was wrong. Yeah. All right. So let's check it here. 10 times 2 minus 3. Well, it'll be 20 minus 3, which is 17. And then I'll have 2 times 2 plus 13 on the other side, which is 4 plus 13, which is 17. And there you go. They match. Yeah, they sure do. All right, that's it for this video. Go ahead and attempt cluster number 3 if you're in class. Mr. Lawrence signing off. Have a good night, everybody.